if you read through lesson 5.7, you're going to find that we're dealing with fractions within fractions. And there's two basic methods that you can use. You can, what they call method 1, which is to solve the numerator by subtracting, in this case, common denominator would be 8. Solve the denominator by adding, in this case, common denominator would be 12. And then perform the rest of your problem's division. The way I like and the way I'm going to focus on is method 2, which is to multiply the entire thing by the lowest common denominator of all the denominators showing. Which, this is example 1, in this case happens to be the number 24. Okay? The number 24 multiplied by 3/4 makes this a 6. 6 times 3 is 18. Minus 8 and 24. 1/8 times 24 over 1. The 8 and the 24 reduce to become a 3. 3 times 1 is 3. So by doing that, I have now made this into that, a nice pretty whole number. 1 times 24, or 1 and 24 don't reduce, so it's 24 times 2, 48. That's the result, oops, we already did that, of that. Then I'm going to do 24 over 1 and 1/12. Looks like a 2 to me. 18 minus 3 is 15. 48 plus 2 is 50. 3/10, I'm thinking that looks like. And that's your answer. And again, this is using method 2. My goodness, method 2. I don't like the other method except for when we're dealing with negative exponents, which we'll get to shortly. But that's a nice, easy example because everything we had was numeric. So it was fairly easy to recognize what the lowest common denominators were here. Let's do one more just like it. 2 minus 1/2 divided by 1 minus 1/4. So most of you could probably see that this ends up being 1/2 over 3/4, and then you divide. But assuming you didn't, the lowest common denominator of the 1, the 2, the 4, and the 1 is 4. So I'm going to multiply everything by 4 to rename this. The 1 and the 4 don't reduce, so 4 times 2 is 8. The 2 and the 4 reduce by a factor of 2. 2 times 1 is 2. That's the result of that. Here, 4 and 1, that's 4. 4 over 4 and 4 reduce, that makes that a 1, so 1 times 1 is 1. Looks like I'm ending up with 8 minus 2, which is 6, and 4 minus 1, which is 3, looks like an answer of 2. Okay? And I know you could have done that one a lot differently and more easily without even working it that way, but I really just wanted you to see how to work it that way. Moving on to example 2 in your textbook. Now this is my example 2. It involves variables, which I know you don't necessarily want to see, but we're going to do our example 2. And here we go. 1 added to 3 over x added to 2 over x squared divided by 1 added to 2 over x. The lowest common denominator is x squared. Okay, the lowest common denominator of 1, x, and x squared, that's an x again, is x squared. So we're going to multiply everything by x squared. If you want to put a 1 under it just for your brain, go ahead. X squared. So the result of multiplying the first piece by x squared is x squared. The second piece by x squared is 3x, because x and x squared reduced. And the last piece is a positive 2. The second piece, nothing reduces, x squared, and that becomes 2x. Okay? So where we're at here is we have to now factor and hopefully reduce. Looks like this is going to be x plus 2, x plus 1, and this is going to be x plus 2. So I factored here, and I factored there. The x plus 2's reduce, leaving me with x plus 1 over x. You might want to say, well, this and this reduce. No, they don't. X plus 1 are together. They are together as part of the factor of that. They are not separate standalone entities. They are together. This is your answer for example 2. And example 3, negative exponents. Everybody's favorite thing. R to the negative third plus S to the negative third over R to the negative 1 plus S to the negative 1. All right. Depending upon how you like to do these, I would make this 1 over R cubed plus 1 over S cubed and 1 over R plus 1 over S. Then I would use my denominator. Lowest common denominator of R and R cubed is R cubed. S cubed, so S cubed. So this is going to be the lowest common denominator of everything. So if I multiply this, remember put a 1 under it, by this, R cubed, S cubed times 1 multiplied by 1 over R cubed, you end up with S cubed. Multiply here by here, you end up with R cubed. Looks like a sum of cubes situation. Down here, multiply, you end up with R squared S cubed because one of the R's canceled. And here, positive R cubed S squared, nothing canceled there. Okay? So let's try and factor this out. This is a sum of cubes. Which factor pattern you guys had a couple sections back? S plus R, so A plus B. And then A squared minus AB plus B squared. And the bottom component, we could pull R squared, S squared out, and that leaves me with S plus R. The S plus R's cancel, boom. And you're left with S squared minus SR plus R squared. That cannot factor any further. R squared plus, R squared S squared. And all that is RRSS. Nothing can reduce here. I know you're thinking, well, wait, that and that match and that match, but not in their entirety as they currently sit. Do they match? That's it for today.